On paper, a project design exists in perfect spatial harmony. In the physical reality of site execution, mechanical, electrical, and structural boundaries collide. For main contractors operating under the JBCC 6.2 agreement, managing these collisions reveals a structural paradox. The principal agent dictates which subcontractors are appointed, yet the main contractor absorbs the total liability for integrating their work. This happens due to privity of contract, establishing a strict legal barrier preventing the employer from forming a direct relationship with the subcontractor. Therefore, all operational risk and site communication must flow vertically, making the main contractor the mandatory bottleneck. This forces main contractors to manage entities they didn't vet or negotiate with, creating an expanded risk profile that must be controlled on site. Under Clause 14.0 for nominated subcontractors, the principal agent explicitly instructs the main contractor to appoint a specific entity, leaving no commercial choice. Furthermore, Clause 14.8 dictates there is no privity of contract between the employer and that subcontractor. Contrast that with Clause 15.0 for selected subcontractors. Here, the contractor chooses the tenderer in consultation with the principal agent, offering marginal commercial control. However, Clause 15.8 confirms the privity rule remains identical. No direct contractual relationship exists. The critical obligation is found in Clause 12.2.9. Regardless of whether a subcontractor is nominated or selected, the main contractor is bound by law to coordinate the program with subcontractors and direct contractors programs. While Clauses 14 and 15 dictate commercial negotiations, Clause 12 ensures the main contractor bears all costs for physical coordination failures on site. Coordination is not just a legal term, it describes the management of interfaces. These are the physical, spatial, and temporal boundaries where different trades occupy the same space. On a Greenfield site, where you build from scratch on an empty lot, these interfaces scale predictably. Trades follow a standard, linear sequence from foundations through to final finishes. This changes in brownfield environments, like active hospitals or malls. When you introduce live service tie-ins and public boundaries, the number of interfaces scales geometrically with every new trade added to the floor. Applying standard Greenfield management assumptions to a brownfield environment creates an exponential increase in risk exposure across 10 specific vectors. To manage the liability outlined in Clause 12.2.9, you must track 10 distinct site risks. 1. Spatial rapproches. This requires 3D BIM coordination before any physical installation begins. 2. Temporal overlaps. When trades stack in the same footprint, it will require hard-linked baseline programming. 3. Tolerance mismatches. Heavy structural variances often conflict with the strict tolerances of facade systems. 4. Design boundary gaps. This is solved through strict scope demarcation matrices. 5. Temporary works dependencies. Safe access requires formal handover certificates between trades. 6. Site logistics. Limited laydown space requires precise just-in-time delivery scheduling. 7. Commissioning sequencing. Complex builds require system-by-system integration testing before handover. 8. Substrate handover. This requires formal accept or reject sign-offs between consecutive trades. 9. Live utility tie-ins. Shutting down active systems requires rigid permit-to-work protocols. 10. Protection of completed works. Per JBCC Clause 17.19, you must actively apportion responsibility for any damage to finished work. Identifying these 10 risks provides the roadmap, but managing the resulting data volume requires a centralized tracking system to prevent minor clashes from compounding into critical path delays. The interface log is the tool used to translate those 10 risks into a manageable 4-step workflow. Step 1. Identify the boundary. Every physical or temporal clash must be isolated and assigned a unique tracking ID. Step 2. Assign a lead. One subcontractor must be contractually designated as the lead responsible for resolving that specific integration detail. Step 3. Consultant approval. The principal agent or technical consultant must sign off on the proposed resolution. Step 4. Closeout. The resolved interface is hard-coding into the master baseline program, locking in the specific dates for execution. This log transforms abstract JBCC coordination requirements into a visible and auditable execution checklist. To be effective, the interface log must be enforced through formal coordination meeting minutes under Clause 12.3. Here are 6 specific phrases to use in those meetings to protect your project's legal position. Phrase 1. The subcontractor is instructed to align their installation sequence with the approved baseline program pursuant to Clause 12.2.9. Phrase 2. Notice is hereby given for a mandatory spatial coordination workshop to resolve routing conflicts prior to installation. Phrase 3. To manage liability handovers, substrate conditions have been formally accepted by the incoming trade, releasing the preceding contractor from subsequent alignment liability. Phrase 4. Pursuant to Clause 17.1, the sequence of works is altered to accommodate unresolved interface constraints. Phrase 5. To avoid rework, a formal hold point is established for joint inspection. No systems shall be enclosed prior to principal agent sign-off. Phrase 6. Notice is given under Clause 27.2 of intent to recover expense and loss from the subcontractor's failure to submit timely coordination drawings. Mastering JBCC 6.2 requires treating the contract as the structural framework and the interface log as the tool for operational execution. It is the mechanism that ensures legal coordination requirements translate into physical